Today is February 2026, and honestly, the landscape of software security, it just shifted under our feet.
Yeah, it really did. It's a massive change.
We're doing a deep dive today on this new announcement from Anthropic. They just dropped a limited research preview for a tool called Claude Code Security. And our mission here is to unpack exactly how this is moving us from basically finding syntax errors to finding actual logic flaws.
Right, because the old way is, well, it's breaking.
We have a math problem, basically,
Right.
a massive backlog problem where vulnerabilities are just expanding way faster than human teams can ever hope to fix them.
The asymmetry there is wild. I mean, we are writing code exponentially faster today than we can possibly secure it.
Yeah.
If you look at the sheer volume of lines committed daily, and then you compare that to the handful of highly skilled security researchers actually available to audit it,
It's a losing battle.
we are absolutely losing. The math just does not work in our favor right now.
And traditionally, the life raft for this has been static analysis. I mean, we've all used these tools. They sit in the pipeline, and they just sort of yell at you for missing a semicolon.
Yes, STERI tools, static application security testing.
Right. It's like a giant spell checker. It looks for known patterns, like you misspelled a word or you left a password exposed.
Exactly. It's a giant game of Control F. It has a rule book of known bad patterns, and it just scans for them.
But Anthropic is claiming this new tool isn't that. It's a shift to AI-driven reasoning, meaning it's not just pattern matching anymore. It's trying to understand the actual intent of the code.
Which is the critical distinction here.
Yeah.
To really get why this matters, you have to look at where that traditional SAST approach fails. Like you said, it catches the exposed passwords or the outdated encryption libraries, the syntax stuff.
The low-hanging fruit.
Yeah, exactly. But it has zero concept of context. It doesn't know what the application is actually trying to achieve. It just knows the grammar of the programming language.
Right, it knows evil is dangerous.
Sure. And that's why developers traditionally kind of hate these security tools. They generate so much noise, so many false positives, because it flags code that looks bad syntactically, even if it's completely safe in that specific context.
Because it's looking at a tree and ignoring the forest.
Precisely. Claude Code Security is completely different because it leverages the reasoning capabilities of these frontier models, specifically Claude Opus 4.6. It reads and reasons about the code almost exactly like a human security researcher would.
It builds a mental model of the app.
Yes. It traces how data actually moves through the different components of the application.
Okay, let's drill into that, though, because tracing data flow can sound a bit like marketing speak unless we ground it. Give me a concrete example of what this actually catches that the old spell checker misses.
Okay, so think about broken access controls. This is basically always on the OWASP top 10 list of vulnerabilities. Imagine you have a web app with a function that deletes a user account. Syntactically, that function might be flawless. It takes an ID, it queries the database, and it deletes the record safely. A static tool looks at that and gives it a gold star.
No SQL injection? Looks great.
Exactly. But the flaw isn't in the syntax, it's in the business logic.
Who is actually allowed to call that function?
Right. Can a regular user just change a number in the URL and trigger the delete admin function? A static tool has no idea what an admin even is. It doesn't understand permission hierarchies. It just sees valid executable code.
But Claude reads it differently.
Yeah, Claude reads it and says, wait a minute. It sees the authentication middleware, it looks at the route, and it reasons that an unprivileged user has a direct path to a privileged action.
It understands the implication. These are the bugs that just sit there silently.
The silent killers. They don't crash your compiler, but they will absolutely crash your company when someone finds them.
Okay, but here is where I get skeptical, and I think you listening to this should be skeptical too.
The hallucination problem.
Exactly. Hallucination. We have all seen AI write code that looks incredibly plausible but is just fundamentally broken. If I'm a security lead, I can't have a tool crying wolf all day about critical vulnerabilities that don't actually exist.
Well, you'd turn it off by Tuesday.
Right, I'd spend my entire week chasing ghosts. So how do they solve that?
That is the #1 barrier to adoption right now. Trust. Anthropic knows this, which is why the workflow they built here is so fascinating. It's a multi-stage verification process. It literally mimics the scientific method.
I was looking at the source on this. It essentially argues with itself.
It does. Step 1 is just forming a hypothesis. The AI says, I think this input field might be vulnerable to this specific attack.
Yeah.
But it doesn't just alert the human right then.
It has to prove it first.
Exactly. Step 2 is verification. It actually attempts to exploit the vulnerability. It tries to generate a proof of concept in a sandbox environment to prove beyond a doubt that the flaw is reachable.
So it's basically doing its own red teaming.
Yeah. And if it can't prove it,
It throws it out.
it discards it. It self-corrects. This acts as a massive filter for false positives. By the time a finding actually hits your dashboard, it's not a hallucination. It's verified.
And they assign severity ratings to these too, right?
Yes, which is crucial for triage.
Yeah.
You might have 100 bugs, but you only have time to fix 5 before the weekend. The tool tells you which fires are actually burning the house down.
Okay, so the human looks at the dashboard, they see the verified finding. But let's clarify the human's role here, because there is a very real fear of AI just autonomously changing production code.
The nightmare scenario where an auto patch takes down the whole system.
Exactly. Nobody wants that.
And Anthropic is explicit about this. The rule is nothing is applied without human approval, period.
It's strictly human in the loop.
Absolutely. The AI is the researcher identifying the problem, and it's the author suggesting the patch. But the human developer is the editor and the final approver.
Because assessing the business impact of a patch is still really nuanced.
Right. And to help with that, the tool provides a confidence rating for every finding. It says, the issue here is how confident I am, and here's the suggested fix.
And this is integrated directly into Claude Code, right? So I don't have to leave my terminal to fix this.
Yeah, which is a huge quality of life improvement. You don't have to context switch to some clunky web dashboard.
Yeah.
You review the suggested patch right in your IDE, and you can approve it with one command.
That friction is still there, though. You have to hit enter.
It preserves human agency while stripping away all the drudgery of writing the boilerplate patch.
All right, I want to pivot to the actual real-world impact here, because the source material had a number that genuinely stopped me in my tracks.
Oh, 500 bugs.
Over 500 vulnerabilities. Let's set the context for this. Anthropic's Frontier Red Team basically dog-fooded this tool internally for a year.
They turned Claude Opus 4.6 loose on production open source code bases.
Right. Not toy projects. The code that literally runs the internet. Code that we all rely on every single day.
And this is code that is supposedly the most heavily audited in the world.
Yeah.
I mean, we've all heard the open source mantra, right? Given enough eyeballs, all bugs are shallow.
That's the whole philosophy. The community will find the flaws.
But then Claude goes in and finds over 500 actionable, critical vulnerabilities.
And these weren't new bugs introduced last month.
No, that is the wild part. Some of these bugs had been sitting undetected in these code bases for decades.
2 decades. It's crazy.
Decades of expert human review. Decades of bug bounties and static analysis sweeps. And these logic flaws just sailed right through all of it.
It completely shatters that many eyeballs theory.
It really does. Because it turns out human eyeballs get tired. We have biases, we gloss over complex routing logic, and honestly, modern software is just too complex for one human brain to map perfectly.
You can't hold the whole state of the app in your head.
You might have a vulnerability that only exists because of how 3 separate libraries interact. Libraries written by different people 10 years apart.
A human just sees 3 clean files.
Right. But the AI has the context window to see the disastrous interaction between them.
It's exposing the unknown unknowns. We all just assumed the skin was safe because nobody had exploited it yet.
Or at least nobody we caught.
Right. Which is terrifying.
It's like turning on the lights in a house you've lived in for 20 years and realizing the load-bearing walls are made of termites.
Great visual. Thanks for that. But that urgency brings up a good point. Anthropic is doing responsible disclosure for all these.
Oh, absolutely. They aren't just dumping 500 zero days on Twitter.
That would be chaotic.
They are actively working with the maintainers of these open source projects to get them patched before any details go public. But just think about the sheer scale of that.
500 simultaneous disclosure processes.
It just highlights the massive hidden security debt sitting in our digital infrastructure.
Which brings us to the core philosophy here, the defender's advantage. Because if I'm listening to this and I'm a threat actor, I'm thinking, wow, what a great tool. I can't wait to use this to attack people.
That's the dual-use dilemma. It's the elephant in the room with all AI security tools.
The same reasoning engine that finds a bug to fix it can find a bug to exploit it.
Exactly. There is zero technical difference in the discovery phase.
So aren't we just handing attackers a super weapon?
It's an arms race. There's really no sugarcoating it. Attackers are going to use AI to find vulnerabilities. That is going to happen. The defender's advantage is purely a timing argument.
Explain that.
The defenders have access to the source code, to the CI pipelines, to the internal documentation first. If we deploy AI reasoning tools right now, today, We can scour our own infrastructure and patch all these 20-year-old bugs before the AI attack tools become cheap and ubiquitous.
So we have a head start
We have a brief window to raise the baseline security of the entire internet.
by burning the low-hanging fruit.
Right. We force the attackers to work much harder. If we close all these logic flaws that have been sitting there, we shift the economics of an attack. It becomes expensive and time-consuming for them.
But we have to move fast. If they adopt this tech faster than we do,
We are in for a brutal decade.
and that explains some of these external partnerships Anthropic mentioned, specifically with PNNL, the Pacific Northwest National Laboratory.
Yeah, that is a huge signal. This isn't just about making sure your startup sauce app doesn't leak emails.
This is critical infrastructure.
PNNL defends the energy grid. They work on nuclear security, systems that literally cannot fail. The fact that they are testing these AI models shows that this is being treated as a national security capability.
And they've also been stress testing it in competitive environments too, right? The capture the flag events?
Yes, CTF events are the ultimate proving ground for this stuff. It's one thing to find a bug in a static repo. It's another to find it in a dynamic, hostile environment where human hackers are actively trying to outmaneuver you.
It proves the reasoning holds up under pressure.
Exactly.
Okay, so practically speaking for the listener, who actually gets access to this right now? Can a regular developer just download it?
Right now, it's a limited research preview. It's gated, mostly for enterprise and team customers.
Makes sense.
But there's a really important carve-out here. They are fast-tracking and providing free access for open-source maintainers.
Oh, that's brilliant.
It's a herd immunity strategy. If you secure the foundational libraries, the stuff everyone builds on, then the whole ecosystem gets safer by default.
You fix the foundation first.
It is the absolute highest leverage place they could possibly deploy this technology.
Zooming out a bit, it feels like we are looking at a fundamental shift in what the security researcher role actually is. We're moving from a world where security is this massive bottleneck to a world where AI essentially scales the human researcher.
We aren't replacing the human, we're giving them an exoskeleton. We have a global shortage of millions of cybersecurity professionals. We can't hire our way out of this hole.
No, we can't train humans fast enough to keep up with the code being generated.
So this tool lets one senior human act like a team of 10. The human sets the strategy, they handle the weird edge cases, and they make the final call. But the AI does all the heavy lifting of the mass cleanup.
It's the only way to balance the equation we talked about at the start.
You have to automate the defense to stand a chance against the automated offense.
It really feels like a pivotal moment. We've talked so much about AI for coding lately, but it's mostly been about generating new code quickly. This shift toward using AI to secure our legacy code feels much more consequential.
It's the required second act. Gen AI built a mountain of code. Now, reasoning AI has to make sure that mountain doesn't just collapse on top of us.
I want to leave everyone with a final thought here, something to mull over. We talked about those 500 vulnerabilities that Claude Opus 4.6 found.
The haunting metric of the day.
It really is haunting, because you and I and everyone listening, we all operate under services, and we just assume the foundation is solid.
We assume someone checked it.
But if a single AI tool over a relatively short period of time was able to uncover 500 critical logic flaws in code we trusted for 2 decades, code that had been reviewed by thousands of human experts, what does that say about the rest of our digital infrastructure?
It says we've been very lucky.
We just shined a flashlight into one tiny corner of a massive dark room. So the question for you to think about is this: what is hiding in the rest of the dark? And more importantly, who's going to find the next 500 bugs first? The defenders trying to secure the house, or the attackers trying to burn it down?
The starting gun just went off.
It really did. Well, thanks for taking this deep dive with us today. Keep your systems patched and keep your skepticism healthy. We'll see you on the next one.